Now we are into the last section of the particular chapter 1, and these are all why questions. Now 17, 18, 19 questions are diagram, so which are written on the board. Let's see what the diagram below represent a portion of a micrometer screw gauge in which the horizontal scale is in millimeter. In millimeters, horizontal scale is in millimeters shown on the board. We say, what is the reading on the instrument? Now, what we're going to do is simply very simple. We count this one, we count this one, whatever this one gives to us, right? That's mx. So this one is 0, 0.51, 1.52, 2.53, right? This one that has 3.00 mm. Now, this, we look at this line. Where this line intersects with this line is at 22. Number 22. Each of these symbol lines was 0.0 1 mm. So in that case, now what we're going to do is scale will now be TS will now be equals to 22, which is 0.22 mm. So I haven't gotten that one now since it's meet at number 22. So the reading will now be equal to what is the main reading now? That 3.22 mm as the final answer for that number 17 question. So we have option A, we have 3.72, B 3.50, C 3.30, D 3.22 millimeter. So that is 1996 YA question number 1, which is correct, which is option D. Now we look at number 18, which is also stated on the board. It said the diagram below would represent a section of a pair of vernier caliper. The reading on the instrument is dash. That means the reading of this instrument is dash. Now we are going to read the main scale. The main scale, what is the main scale of this particular reading? The main scale before the 0 mark, this 0 mark, 0 centimeter mark of the of the vernier scale. So this 5.1, 5.2, this is 5. So 5.1, 5.2. So this 5.20 centimeter. Now, what is the vernier scale or the VS scale? Now we look at the point where the vernier and the main scale, where the kiss, where they intersect. Now this is the MS, this is the VS. So we 1, 2, 3, 4, 5, 6. It meet at number 6, so that is 0.06 cm. So the total reading for that question will now be 5.26 centimeter for the main reading. The readings for number 18. Now this for number 17. Now we go to the last one. It said for the diagram number 19. It said the diagram below is a micrometer screw gauge. That is number 19. Determine its reading. A 2.44 millimeter, B 2.46 millimeter, C 2.86 millimeter, D 2.96 millimeter. Now let's we don't consider all this. So what we look at, don't allow this one to distract you. Then the 0 mark will be taken by the by this part, which is there will now be 1.52, 2.00 millimeter is the first scale. Then after taking the first scale of the micrometer screw gauge that is given to us, we look at the second one, which is the point where this line actually of the micrometer screw gauge intersects with this line, and that should be at 46. That is 46. So this is 46. So 0.46. Each of them is 0.01. So it will be 0.46 millimeter. So if you add them together, if you take an addition of the two of them, that would give us 2.46 mm, and that will be our final answer for that one, which is option A says 2.44, B says 2.46. Option B is the correct answer. Number 20 says which of the following instrument is the best for measuring the diameter of a thin constantan wire? I don't need to waste time on that. Anytime you want to measure the diameter of a wire, I've told you, use micrometer screw gauge. So the answer to that question is option C. A say vernier caliper, B meter rule, C micrometer screw gauge, D vernier caliper. So the answer is C. Number 21 said a chemical balance is used for measuring dash. A volume, B mass, C thickness, and D density. The chemical balance is used for measuring mass, not what. To measure volume, you can use measuring cylinder. Then to measure density, you can use what? Barometer. You can use barometer. Barometer. Hydrometer, sorry. You can use hydrometer. Barometer is what? Is an instrument used to measure density. Density is what? For what? Barometer. Then we have the manometer for measuring gas pressure, as case may be. So those ones are what? Number 22. Which of the following statement about spring balance and chemical balance is not correct? I think we have answered similar like question like this, so I will not waste time. A says the chemical balance operates on the principle of moment. Yes. B says spring balance operates on Hooke's law. Yes. C says what? Either may be used to measure weight of object. No. Then D says the reading of the spring balance changes over the surface of the earth, while the chemical balance remains constant. Chemical balance is used to measure mass. Spring balance is used to measure what? Weight. So the question, they say, which of the following is not correct? Okay. Which of the following statement about a spring balance and chemical balance is not correct? So I believe option what? C. Either may be used to measure the weight of substance. No. A is correct. Chemical balance operates in the principle of moment. B is correct. Spring balance operates in the principle of Hooke's law. D is correct. The reading of spring balance changes over surface of the earth. Yes, I've told you how it changes over the surface of the earth. It is lower at the equator and higher at the pole, because at the equator the radius is higher. Don't forget there are some factors that affect weight, which I will want you to type at the comment section. What are the factors that changes the weight of a body? So I want to list them. There are factors by which weight are affected. There are things that affect weight. Look at those factors and list them for me. There are about 3 or thereabout of them. Type it and send it to the comment section. The next one says the reading of a spring balance changes over the surface of the earth. Yes, correct. Why the chemical balance remain constant? Chemical balance is used to measure mass, so it will remain constant because the mass of a body is a quantity of matter a body contains. And matter is anything that has mass and occupies space. So in that case, matter is a constant fundamental quantity. Number 23. So the answer is C for that one. Number 23, which is using vernier caliper, which of the following reading gives the correct measurement of length of a rod? A say 4.1 centimeter. Yes. Measurement of length of a rod. B says 4.13 centimeter. That is for vernier caliper. C says 4.125 centimeter. D says 4.1254 centimeter. So using vernier caliper, option A is meter rule. B is vernier caliper, which is 4.13. C, micrometer square. D, no. So the answer is B, vernier caliper. Number 24, which is the last one for this section. So when we come back, we now know that we'll do this is 24. So which of the following terms has different dimension from the others? Which of the following terms have different dimension from the others? Now, don't forget, stress is what? Number 1 is stress times strain. Stress is what? Force over area. Strain is what? Extension over length. And strain is dimensionless. Force is ml t minus 2. Area is what? L times L. So this one cancels it. So the dimension for stress times strain is equal to what? ml minus 1 t minus 2. Stress times strain, if we add half to it, we call it what? Energy density. Please take note of that. Is energy density. Energy density also is what? Energy over what? Area. Don't forget, energy density is half times stress times, if I add half to it, over volume. Don't forget, volume is force times what? Energy is force times distance. Volume is area times what? Length. And if you compare this one, you will discover that almost have the same thing. So option B says what? Stress over strain. Yes, stress has the same divided by strain. This is what we call what? Young modulus formula. Stress over strain is Young modulus, and Young modulus is what the same dimension as this, which is what ml minus 1 t minus 2 is stress divided by strain is what dimensionless. So since strain is dimensionless, it retain its what dimension, which is this one. Then the last one, which is what second to last, pressure. Yes, pressure. C is pressure, is same dimension. D is a torque. Torque is the same dimension as what moments. Moment is same thing as work. Work is same thing as energy. So energy, what is dimension for energy? Energy is what? Force times distance, which is ml t minus 2. Please master force. Very important, you master force times distance. So that will give us what? ml square t minus 2. So this is dimension for what? For energy, which is torque. And we check others. Pressure are in this category of which is option C, ml minus 1 t minus 2. Stress over strain, which is Young modulus, is also part of it. Stress, because this is dimensionless, is also what this one. So the only answer that is all that is different dimension from others is option D. This is 2024 YA question number 30. I believe I'm able to convince you, not to confuse you, that physics is very easy. Ensure you follow me if you are writing JAM next year or YA, or you are writing any professional exam that require physics. Please ensure you would like the button and subscribe. You are returning. If you are a new viewer, you are just meeting me for the first time. If you are a new or returning viewer, thank you for watching. My name is Engineer Holiday. God bless you for watching my video. God bless you and remain blessed. Thank you.